Okay, let's work out the answer for this question. How much 0.05 molar HCl, hydrochloric acid, solution can be made by diluting 250 mils of 10 molar HCl? So the first thing we need to do is recognize that we are talking about a dilution. We're going to use this formula C1 V1 equals C2 V2. And we need to recognize which variables we have. So we want to know which of these C1, C2, V2, V1, which ones do we actually have? What are we looking for? So if we break down this question and unpack it a bit, it's asking us how much 0.05 molar HCl solution can be made by diluting something. So the 0.05 molar HCl solution is our final solution. That's our final concentration. If you were at all questioning that, you could look at the difference between the two concentrations. So you're making a solution that's 0.05 moles per liter, and you're starting with a 10 mole per liter solution. So you can see that the 10 molar solution is much more concentrated. That's a bigger number. And the 0.05 molar solution is your diluted solution. That's a lower concentration. So we can label that right away in our question. That's our C2. That's the final concentration, which means the 10 molar is the C1 in this question. And then what volume do we have? We've got 250 mils of the 10 molar HCl. So that's the initial volume, okay, that we're using. So here is our V1. You'll have to ignore my pen, it just likes to make some extra lines. Okay, so what are we actually looking for then? How much solution, how much of the diluted solution? So we're trying to figure out how much solution can we get in the end when we dilute this 10 molar solution by taking 250 mils, adding some water to get a 0.05 molar solution. So we are solving for V2. That's the unknown. We can go ahead and plug in everything we have right now, or we could rearrange it right now to solve for V2. I'm going to go ahead and rearrange it. I need to divide both sides by C2 so that I get V2 is equal to C1 V1 C1 V1 divided by C2. And now that I know who C1, V1, and C2 are, I can go ahead and plug them into my calculation because I know what those variables are. So I'm going to go ahead and do that. So I've got my C1 is my original concentration, which was 10 moles per liter. Keeping my units in my calculation here, multiplied by V1, and my initial volume was 250 mils. It's okay to have my units of volume in milliliters as long as I know my answer is going to come out to have units of milliliters as well. My C2 on the bottom here is going to be the 0.05 moles per liter. Alright, and now I'm ready to go ahead and calculate that out. So 10 times 250 divided by 0.05 gives me 50,000. Wow, I can make a lot. Milliliters is my units, and I just solved for V2. So that's the total volume that I can make in this dilution. So that's how much I'll have at the very end. Thinking about sig figs before you finish, if you go back to all of the data that we used, we had one sig fig in our concentration here, 0.05. There's only one sig fig, the 5. There are 2 sig figs in the value 250 mils, and there is 1 sig fig in the number 10 because there's no decimal place there. So just that 1 counts. So in total, the least number of sig figs that I have here is 1, and so I'm only allowed to have 1 sig fig in my answer. But the way I've written it is fine. So if I write it as 50,000 with no decimal place, that's correct with 1 sig fig. The other way I could write this is 5 times 10 to the exponent 1, 2, 3, 4. There's 4 zeros there. And I need to have my units of milliliters. So both of those are totally and equally correct.